Hello. In this tutorial, I will show you how to create a calculator with Python and PyQt5. It's going to end up looking like this and will function like any basic calculator. And the steps I will be going through happen at these times if you look for specific things. As always, if you want to use PyQt, you need to install PyQt because it doesn't come along with Python by default. So either in the PowerShell or in the terminal, type pip install PyQt5 and you should see the installation animation. And if you can import PyQt5 in the Python script without getting an error message, you are ready to go. Let's establish the basics now. Before starting this project, let's talk about GUIs, or graphical user interfaces. All that means is that when you use your computer, you click on icons and buttons instead of typing text. While Python is a powerful language that can be used from exploring planets to running servers to analyzing data, very little of that needs a graphical user interface. And as a consequence, Python doesn't really have tools to display graphical elements like buttons or sliders. For that, we need additional libraries. There are quite a few available for that. You can find all of them in the Python documentation. The default one is called tkinter, which is short for TK interface. And while this one is installed along with Python, it is not a core part of the language. In fact, tkinter is not even made in Python, but in a language called tcl-tk. Another important library is the Qt framework, which was originally developed for C++, but it can be used in Python either with PyQt or with PySide. There's a bit of history why there are two modules for the same purpose, but the two are really similar, so it isn't something you need to worry about all that much. And finally, there's Kiwi, which is based on OpenGL. This one is particularly good if you want to make a mobile app with Python. Which library you choose depends on quite a few factors, and each has advantages and limitations. I will use PyQt for this tutorial because it is nice and simple. But with a little bit of tinkering, you could create the same app with the other libraries as well. And before I get into the logic of PyQt, I have to warn you that you need to have at least a basic understanding of object-oriented programming in Python. Otherwise, nothing is going to make sense. Specifically, you will need to know how to create an object from a class, how to use self and inheritance with super, but you won't need multiple inheritance or decorators, at least for this tutorial. And besides that, you should also know about lambda functions. With that out of the way, let's talk about how PyQt works. Essentially, every PyQt program is built on two objects. One is called QApplication, the other is main window. The one you will work the most with is the main window object, because this one handles the graphical elements and the logic of the application itself. QApplication does all the stuff that happens under the hood, like event handling and initializing the modules. Most of that is automatic though, so you don't actually have to worry all that much about this part. Once those two are created, you have a basic framework that you can add visual elements to. In PyQt, these are called widgets. A widget could be a button or a field. It could also be a container that holds other elements. For the purpose of this tutorial, we only need some basic ones. I will use one called QPushButton, which is a very simple button and perfect for the number and operator keys. Then I will use the widget called QLineEdit, which can be used to input and display text. In the calculator, this one is going to show the results. And finally, I will use QWidget, which is basically just an empty container, which is perfect to create structures on the application. And that is everything we need to get started. Let's jump into the code with that. First, we need some imports. We don't actually import all of PyQt. Instead, I will only import pyqt5.qt widgets, and I call it qtw. I took the naming convention from Alan Moore's book, Mastering GUI Programming in Python, which is an excellent book that I would recommend if you want to learn more about PyQt. Qt widgets holds all the widgets, and is enough since we are only going to make a simple app without much styling. And with the import out of the way, let's create the class that holds all the elements that will be shown to the user. For that, I will need to create a class that I will call main_window, and that inherits from qtw.qWidget. Then I add dunder init, and within that I also call dunder init on the class we inherit from with super. And after that, I call self.show. Let me go through this and explain. We start by creating a class in the usual way. And this class will inherit from QWidget. The main window class itself is what will hold all the visual elements, and whatever it inherits from will be the base all the other elements will be placed upon. In this case, QWidget is just an empty container, so we start with a completely empty window. And next, I initialize the attributes of the class with dunder init. And for now, this will be empty except for the inheritance from the apparent class, which is needed to make it function properly. And after that, there's self.show, which displays all the elements of the object created from the main window class. Right now, it wouldn't show anything except an empty window because we haven't added any widget yet. That will happen in a little bit. After the main window class, I need the line app equals qtw.queapplication. And I pass in an empty list. You could pass in more here for additional functionality, but I just don't need it. And well, that creates the Q application that keeps track of all the stuff under the hood. The two things left to do are to create an actual object from the class. I call it MW and assign it the class main window. And with that, we have the two objects that maintain our application. The one thing left to do is to add app.x_, which tells Python to run the application. And the underscore is important to avoid some naming conflicts with Python. And that is it. If I run the code now, you should be able to see an empty window. It can be resized and closed, but that is about it. So let's add the graphical elements next. To add a widget to the window, all we need is to attach it to the class. So effectively, the attributes of the main window become the graphical elements. For a really simple example how this works, let's add a title. In the init function of main window, I add self.setWindowTitle and insert a string calculator. If I run the code now, we get a title for the window. And a similar pattern is used to add all the buttons and labels. But there's one step in between, and that is the layout. You see, the title can only go in one place, so it doesn't need a layout. But if I added a button, PyQt wouldn't know where to place it, so it wouldn't show it at all. Instead, the structure we need is this. We have an empty container right now. To that one, I will add a layout, and on this layout, I will add the button and the labels. There are a couple of different layout styles. Some of the big ones are QV box layout and QH box layout. The V and the H stand for vertical and horizontal respectively. If I add one of these, the widgets would be placed in a vertical or horizontal arrangement, which wouldn't be useful for a calculator. Instead, I will mostly rely on what is called a Q grid layout, which gives us a two-dimensional grid that elements can be placed on. The layout that I will be using for this project is going to look like this. On the window, I create a Q box layout. That one will hold a container. And inside of that container, I add a Q grid layout. And in this grid, all the calculator elements will be placed. Now you might be asking why I don't just put a grid inside of the main window. And that is a very good question. Basically, it is just done to keep the code a bit more readable and lean. I will come back to this one in a little bit. So in the code, I add self.setLayout and insert qtw.qvBoxLayout. Now we have a layout for the main window, but we can't see it because it's just a layout. Let me just add a single button to illustrate. I will add a variable btn1 and assign a qtw.qPush button and insert a string test. If I run the code now, we can see that we can't see anything, except that the window has become very small when we launch it. To make the button visible, we need to attach it to the layout first. So in the code, I add self.layout.addWidget, and into that I pass btn1. If I run the code now, we can see the button. We also get the little animation when we press it, but nothing much happens yet. That part will come in a little bit. And just to reiterate what happened. First, I created a layout on the main window with QVBoxLayout. Then I created a button widget called btn1 on the next line. And this button was added to the layout of the main window. And that is the basic way how to add widgets to the same window. And it doesn't matter what widget you want to add. They are all added in the same way. So you could add a button or a text field, or you could add a container that itself contains other elements. That last part is what I will do actually. Essentially, I will create another function, and in that function, all the buttons and labels will be generated. And still within the function, they will all be added inside of a container widget, and then only this container will be added to the main window. So back in the code, I deleted 2 lines for the simple button and create a function inside of the class and call it keypad and insert self. On the first line of keypad, I add the variable container and assign it qtw.queue_widget. This is going to be what holds all the other elements. And on this container, I set the layout to be a grid layout with container.setLayout, and I insert qtw.queueGridLayout. And with that, we created an empty container with grid layout that is part of the same object as the empty container with the vertical layout. Now I only need to create and add all the widgets to the first container and attach that one to the second one. So let's add all the widgets now. The widgets I want are the following. I want a line that displays all the output, then 2 buttons with result and clear, and then the buttons from 0 to 9, and obviously the operator keys. And all of that is going to involve quite a bit of typing because every single element needs to be added manually. I already inserted all of the buttons so you don't have to watch me type for too long. I started with the line that displays the text and put it in a variable called result_field and assigned it qtw.queueLineEdit without any arguments. Next, I added the 2 buttons for entering and deleting the numbers. Both are just plain buttons. And then I created the 10 buttons with the numbers from 0 to 9. Each of them is stored in their own variable. And finally, I needed the keys for the operators, so a button for plus, minus, multiplication, and division. And with that, we have created the widgets, but now we need to add them to the layout. To achieve that, let me explain how queueGridLayout works. Essentially, this kind of layout creates a grid automatically for you, and that grid grows depending on how large it needs to be. Its top left field has the coordinates 0 and 0, and you just need to add fields by specifying the row and the column. And as soon as you place an element, the grid grows large enough to incorporate it. And by default, each element takes in 1 cell of the grid, but you can specify elements to span over a number of cells. And that covers the basics. So in the code, you still need add widget and insert 5 arguments. The first is the widget you want to place. The second is the row, and the third is the column. And those are the arguments you absolutely need. The final 2 are to specify how many cells the widget should occupy. So the 4th element is for the number of rows it takes, and the final one how many columns it occupies. And with that one out of the way, we get to even more typing because we need to add every single element we created earlier to this layout. Again, I prepared this one to save some time. So on row 0, I have the result field that spans 4 columns, so it takes up the whole space of this row. On row 1, I have the result and the clear button that each take 2 columns. From row 2 to row 4, I always added 3 buttons followed by an operator button. And on row 5, I added the button for 0 that spans 3 columns and is followed by the final operator. And to finish things off, I just need to add self.layout.addWidget and insert container, which adds the container with the buttons to the actual main window. And all of that happens inside of a single method that is neat and tidy. And that was the reason why I didn't just add the grid layout straight to the main window. And if I run the code now, we can see all the buttons. They don't do anything just yet, and the styling is boring, but it is a start. Although, before I go to the next section, I will change one small thing, and that is to add self before the result field, both when I create and also when I place it. This is to attach the result field to the object itself and make it accessible from outside of the method. Essentially, all of the buttons only exist inside of the keypad method for now, and we can't access them from the outside of this method. And if that sounds super weird, have a look at some of the tutorials on object-oriented programming. Without that, PyQt is really inaccessible. Right now, the styling is fairly bland though. And if you scale the window, things get even worse. And sadly, both styling and scaling are topics that easily require their own tutorial. So I won't cover it in this video. But we can do one quick thing to improve things a little bit. There are default styles that we can apply. The one we have right now is pretty ugly, and the better one is called Fusion. To apply that one, I need to go to the end of the code just before the execution and type add.setStyle and insert qtw.stylefactory.create and insert the string Fusion here. This tells the Q application to apply a certain style when it gets the widgets from the main window. So if I run the code now, things are looking a little bit better. Still not great, and the scaling is weird as well, but it's something. Let's make the calculator do stuff now. Right now, you can type into the text field and click on the buttons, but there's no reason to do that because they have no functionality. And to add that, I need to cover two important concepts: signals and slots. It's actually pretty simple. Every widget can emit a signal after a certain event. So if a button is pressed, it sends a signal to another widget. And that widget ideally has a slot to receive that signal. And that's the theory of how widgets communicate. The only signal I will use is called clicked, which is emitted when a button is pressed. And every single button will be able to send that one. I will also only have a single slot, and that is for the text field to change its text depending on what button is pressed. For a simple example, here's the result button. If I wanted to emit a signal when pressed, I will need to emit an argument called clicked, and what I assign needs to be a function. And to be clear here, I assign the function itself. I do not call it, so no brackets after it. For simple things, we could either create a function without parameters or use a lambda. In case you didn't come across a lambda, it is basically a one-time use function without a name, and it gets executed whenever you create it. It's a really useful concept. Check it out if you've never seen it before. But what if you wanted to execute a function with a parameter? Well, you would just need to put the function with the arguments inside of a lambda function. I will make use of that quite a bit actually. Let's do a simple example first before I jump into the logic of the calculator. Say, I want to display the text test when I click on the result button. So on that button, I add clicked equals lambda, and to target the result field, I need self.resultField.setText. And insert the text I want here. So the string test. If I execute the code now and press the enter button, we can see the text test. But obviously we need more sophisticated logic. So I will need a few more methods and also insert arguments into them. And that is why the result field got the self, so that other methods can access it. Let's talk about the logic needed for the calculator. It is a little bit more complex. I start with a method on the number keys. So whenever one is pressed, a method is triggered with an argument. I call it numPress. For example, when I press the button 4, numPress is called with a 4 passed into it. And I will have another method for the operators that I will call funcPress and insert the operator as an argument. So it's fairly similar to the buttons. That way, I get the signals with the appropriate information in them. My next problem is that I want to display the numbers as the buttons are pressed and get the result when the enter button is pressed. Let's work on the first problem, that numbers appear in the result field when pressing the buttons, and that they are properly separated when you press an operator key. To achieve that, I will create two lists. One is called temp_nums and the other fin_nums. And the logic is going to evolve around these two. In the simplest case, only numbers are pressed and the operator keys haven't been touched. In that case, when a number key is pressed, the associated number is stored in the temp_num list as a string. And when I press multiple buttons in a sequence, that sequence of numbers will be stored in that list, all as a string. So if I pressed 4, 2, and 0, I would have a list with the strings 4, 2, and 0. Why I use strings will become clear in just a little bit. But this step is finished by just joining all the elements together as a string and passing this as text into the result field. So that covers just pressing the buttons. Now to the operators. Once an operator is pressed, another method is called. In that one, all the values in the temp num list are joined together and the resulting string is stored in the fin num list. And the fin num list also gets the operator that was clicked on appended as well. To keep with the earlier example, the 4, 2, and 0 will become 420, and if I press plus, the fin num list would have the strings 420 and plus. Also, pressing any operator empties the temp num list, and this function also changes the result field text to display the joined elements of the fin num list. Now we have a problem though. After I pressed an operator, I can see a number plus the operator. But if I pressed another number, I can only see a number. That can be fixed by changing the method for pressing a button. I just need to add an if statement that if there is something in the fin num list, display that before the content from the temp num list. And if fin num is empty, just display the temp num material. And with that logic, we have the text display covered. Now we just need to do the calculation part. And the main thing we have to figure out is how to make Python do the calculation we stored in the list. Luckily, there's a function for that. It's called eval. And it evaluates a string. So if I have a calculation inside of a string, it gives me the result. So when the enter button is pressed, I turn all the content of the fin num list and whatever is left in the temp num list into one big string, evaluate it, and then add an equal sign and the result to the string. And all of that gets displayed in the result field. And the last thing now is to add a function for clearing if you made a typing mistake. So the clear just erases whatever is in both lists and sets the text in the result field to an empty string. And that is the entire logic you need for the calculator. Let's implement all of this in the code now. I start by adding the two lists in the init method of the class. So right after calling super. Both are empty for now. Next up, we are back to some typing. For every single button, I need to add a signal. Again, I typed this part already to save some time. Both the result and the clear button have their own method. Since neither has a parameter, I just pass in the method without calling it. Then I have the number button. They all have the same method but different arguments. So I have lambda and insert the method with the argument here. And the same logic applies to the operator buttons, except that they have a different method. Now we just need to define those 4 methods and things are nearly done. I start with num_press. And the parameters are self and key number. First, I add the number from the button to the temp nums list. Then I create a local variable I will call temp_string and assign it the join string of the temp num list. And if something exists inside of the fin num list, I want to print that as a string, and if it doesn't, then I just want to print the temp num list as a string to the result field. And that finishes the numPress method already. Now to the operators. This one is called func_press, and it takes in self and the operator as parameters. In this function, I add all the temp num elements into a string and append it to the fin num list along with the operator that was pressed. And then I empty the temp num list and set the result field to whatever is in the fin num list, as a string obviously. And to calculate the result field, I work on the func_result method. This one only takes self as the parameter. It first takes in all the elements from both lists and turns it into one long string. I will pass it into a variable I will call fin_string. And then I create a variable I will call result_string. This one will get the result of the previous string. So eval fin string. And on the next 2 lines, I add an equal sign and the result of the original string. And then I display the result in the result field. And to finish things, all that is left is to work out the clear calc method. It only takes self as a parameter, and all that it does is to empty both lists and set the result field empty with the clear method. And that is it. If I run the code now, I have a working calculator. Sadly, it's really buggy. If I had an empty field and pressed enter, the calculator would crash. Also, if the last element in the string is an operator, we also get a crash. But these are mostly minor problems. If you got this far, I'm sure you can fix this yourself. And it's true that it looks a little bit boring and that it's also quite buggy. But you know, the first step to being good at something is to be bad at something. So if you work on the calculator and check out Alan Moore's book, you can vastly improve it. But that's it. I hope you enjoyed this tutorial. Let me know in the comments if you have any question. Otherwise, for the next week, I will show you how to make a fancy graph about the decline of The Simpsons. I will see you then.